In the previous video we discussed about the algebraic proofs, and now we will be going to study the principle of duality, and will also consider the introduction to minterms, maxterms, and we will study the conversion of an expression to canonical SOP or canonical POS expressions and interconversion from SOP to POS also. So come, let's begin. Now let's learn how to find dual of an expression. By the term dual we mean another statement. As we have learned 11 laws of Boolean algebra, we saw that for every law there were two statements. Those two statements were dual of each other. How do we find a dual of an expression or a statement? We have to follow the principle of duality. Here is the principle of duality. It covers 4 points. The first point states that replace every dot with plus. We have to replace every dot with plus, replace every plus with dot, that means reverse the statement, dot with plus and plus with dot, replace every 0 with 1 and 1 with 0, that means we have to replace every false with true and every true with false. Consider this example. This is the absorption law. This is absorption law. Absorption law states x multiplied by x plus y gives x. Its dual can be replace this dot by plus, replace this plus by dot. There are no 0 and 1, so only this much is possible. So we get x plus xy gives x. You can see that this was the first statement of absorption law and this is the second statement of absorption law. If we again do its dual, we get x dot x plus y gives x. So we can see that the two statements of every law are dual of each other. So I hope the duality is clear to you. Now the next topic is deriving Boolean expressions. In this topic, first moving on to further, I must explain you some basic terms and definitions related to this topic. Each variable in an expression is called a literal. Suppose this is an expression x plus yz bar. It is an expression, then each variable, that is x, y and z. Z bar is a derivation of z only. So x, y and z are three variables. These variables are called literals in Boolean algebra. X, y, z, there are three literals in this expression. So based on this understanding, the term which is a product of two or more literals is called a minterm. From this expression, see which term is a product of two or more literals. This term, obviously y and z bar, two literals are there, it is a product of two literals. So these types of terms are called minterms in Boolean expressions. And the term which is a sum of two or more literals is called a maxterm. Suppose there is some expression, say a plus b, then a and b are two literals, there can be more than two also. There are three literals. Sum of these three literals, it is called the maxterm. If there was product of the three literals, it is called the minterm. If it is there of two or more literals addition, it is called maxterm. So I hope minterm and maxterm are now clear to you. Based on minterm and maxterm, there are two terms, SOP and POS. SOP stands for sum of products. What are products? Minterms only. Sum of minterms. We can also say sum of minterms. And POS, product of sums. What are sums? Maxterms. Product of maxterms. So these were the basic definitions. I hope it is clear to you. Now we move further. There is one more term, canonical expression. The term canonical expression stands for expressions which have all the terms as minterms or all the terms as maxterms is called a canonical expression. Suppose there is an expression in which all the terms are minterms or all the terms are maxterms, then it is a canonical expression. Suppose consider this example, xy plus yz plus x bar yz. This is one term, this is second term, this is third term. One term is a product of two literals, second term is a product of two literals, third term is a product of three literals. So it is an expression with minterms. So it is a canonical expression. Suppose consider this example, x plus y is one term, y bar plus z is another term, x bar plus y bar plus z is another term. There are three terms, but all the terms are maxterm. So it is also a canonical expression. So I hope so canonical expression is also clear to you. Now we have to derive a canonical SOP expression from the truth table. We will be given a normal expression, a Boolean expression, and we have to convert it into SOP expression by using truth table mechanism. So to do this, there are 4 steps, 1, 2, 3 and 4. I recommend you to note this down in your notebook. Side by side, I am explaining you each and every point. The first step says, for the given expression, prepare the truth table. Suppose there is some expression, prepare the truth table with the number of inputs and the final expression column. Then add a new column named Minterms to that table. Add a new column whose heading is Minterms. The third step says, select the rows for which output is marked 1. Output is the value of the expression. In any row, if the output is 1, you select those rows with a tick mark or correction mark. Then fourth point says that only the selected rows have to be filled for the column Minterms. The column which we made for Minterms will be filled only for those rows that are selected in step number 3. And how will the entries be? Entries will be like this, x, y, z, because we have to fill Minterms. Entries will be like x, y, z. And how will we decide the entries? We will see the values of x, y and z in the truth table. If there is a 0 for x, y or z, any of the 3, we will put a bar on that literal. Suppose if x and y are 0 in that particular row, then the entry will be x bar, y bar, z. The thing which is 0 will be marked with a bar. This is the theoretical explanation. Now we will do one example, then you will be more clear. The first type of question in your exam will come like this. Convert this expression to canonical SOP. So first thing we have to do is we have to construct the truth table for this expression. That is the step 1 that we wrote just now. There are 1, 2 and 3, x, y, z, 3 literals. We make column for x, y and z. 4041, 2021, 2021, 01, 01, 01, 01. Side by side we have also made a column for x bar, y bar and z bar by inverting the outputs. Similar way in z bar also. So now for this expression, first we need this and then we will add all this. X bar y, this is x bar, this is y. 1 into 0, 0. 1 into 0, 0. 1 into 1, 1. 1 into 1, 1. 0 into 0, 0. 0 into 0, 0. 0 into 1, 0. 0 into 1, 0. X bar y is complete. Now x bar z bar. This column and this column. Mark them, this column and this column. 1 into 1, 1. 1 into 0, 0. 1 into 1, 1. 1 into 0, 0. 0 into 1, 0. 0 into 0, 0. 0 into 1, 0. 0 into 0, 0. So x bar z bar is also complete. Now y bar z. This is y bar, this is z. 1 into 0, 0. 1 into 1, 1. 0 into 0, 0. 0 into 1, 0. 1 into 0, 0. 1 into 1, 1. 0 into 0, 0. 0 into 1, 0. Y bar z is also complete. Now this column is addition of these 3. 0 plus 1 plus 0 will be 1. 0 plus 0, 0. 0 plus 1, 1. 1 plus 1, 1. 1 plus 0, 1. 1 plus 0 plus 0, 1. 0 plus 0 plus 0, 0. 0 plus 0 plus 1, 1. 0 plus 0 plus 0, 0. 0 plus 0 plus 0, 0. So this is our final expression. Now step 2 said that we have to mark only those which have 1 in their output. This one, this one, this one, this one and this one. So 5 rows are selected. 1, 2, 3, 4 and 5. We have to select only those rows in which output is 1. Now for the selected rows we have to fill the minterm column. For the row number 1, we see x, y and z values. This is x with double line, y with double line, z with double line. See these three columns. X is 0, y is 0, z is 0. So there will be bar on all the three. X bar, y bar, z bar. This is the entry for the first row. Now for the second row, x 0, y 0, but z is 1. So bar will be on x and y. Anything which is 0 will have bar. Now for the third row, x is 0, y is 1, z is 0. X 0 and z 0, y is 1. So x and z will be having bar. Now for the fourth row, x is 0, y is 1 and z is 1. Only x is 0. So bar will be on x only. X bar, y, z. Now for this row, this one, x is 1, y is 0 and z is 1. X1, Y0, Z1. So bar will be on Y only. X, Y bar, Z. So this is the column of minterms that we have made. Now our SOP expression will be, SOP is a canonical expression in which all the terms are minterms, sum of products, sum of minterms. We have to do sum of all the products, that means sum of all the minterms. Our minterms are, first minterm is x bar, y bar, z bar. This is one minterm. Second minterm is x bar, y bar, z. Third minterm is x bar, y, z bar. Fourth minterm is x bar, y, z. Last minterm is x, y bar, z. So these are all the minterms that we got. Now SOP is sum of products. These are all products, or we can say minterms. Sum of products means we have to do sum of all that terms. So this is our required SOP, canonical SOP expression. We have converted this expression into canonical SOP expression, which is this one. So we will consider one more type of question that will come in exam. The second type of question you can get for canonical SOP is of this type. They will not give you expression, they will directly give you the truth table and you have to write the equivalent canonical SOP expression. This question is 50% less confusing than previous one. The previous question gave us an expression. We constructed a truth table for that expression and then checked the outputs, which are 1, selected those rows and wrote the corresponding minterms. But in this question, we have already got the function. Function means the output for which we have to calculate the minterms. So we have to directly select the rows with 1s and write the equivalent minterms. It is so much simple than the previous question. So for this row, output is 1. We will see x, y, z. X is 0, y is 1 and z is 0. So there will be a bar on x and z because there are zeros. X bar, y, z bar. For this one, x is 1, y is 0, z is 0. So bar on y and z. X, y bar, z bar. For this one, x is 1, y is 0, z is 1. So bar will be on only y. X, y bar, z. So the equivalent SOP is, first write all the minterms, x bar, y, z bar, x, y bar, z bar, x, y bar, z. These are the minterms. Now we have said sum of products. These are products. We have to do their sum. This is the SOP. So previous question had an expression. We had to calculate each and every term, then the whole expression. Then we got some output. From that output, we selected the rows which had 1. But in this question, we directly see the function where output is 1 and simply compute the SOP. So I hope both the types of question is clear to you. You can practice the questions from any reference book. Now we will move on to POS, product of sums. Now we will learn how to derive canonical POS expression. Previously we learned how to derive canonical SOP expression. Now we are doing POS. So these are the 4 steps that are required. As in case of SOP also we considered 4 steps. There are 4 steps for POS expression also. The first step states that make truth table for the expression. We make the truth table for the expression, then we select the rows which have 0 as output. Note that in case of SOP, the rule said that we have to select the rows that have 1 as output, but in case of POS, we have to select the rows which have 0 as output. Third step, make a new column Maxterm in the table. In case of SOP, we made Minterm column. Now in POS, we will make Maxterm column. The fourth rule states that fill the Maxterm column for the selected rows in the way x plus y plus z. As we have made a Maxterm column, Maxterm is of the form of addition of literals, so x plus y plus z will be the form, and we have to put the bar if any of the literal has input as 1. In case of SOP, we put a bar on the literal if it has input as 0, but in case of POS, we will put a bar if the input has 1. So it is just reverse of SOP. In case of step 2, we selected rows which 1 has output. In SOP, now 0 as output will be selected and bar will be on 1 now. That is, if x is equals to 1 and z is equals to 1, the Maxterm will be x bar plus y plus z bar. In case of SOP, if x and z were 0, then bar was placed. But now, if x and z are 1, then bar will be placed on them. So these are the 4 rules. Note it down in your notebook. Then we will do one example. Now the question is to convert this expression into canonical POS. This is the first type of question. So we first draw the raw truth table. X, Y we have drawn. There is no Z. There are only 2 inputs, X and Y. So there will be 2 raised to the power 2. That is 4 rows in the truth table. 2 0 2 1 0 1 0 1. X bar opposite of X, Y bar opposite of Y. Now in this expression we need X bar Y, XY bar, XY whole bar and X bar Y bar. So we make column for each of them. This is X bar Y, XY bar. XY we have made to calculate this XY whole bar, then X bar Y bar. So now let's solve first X bar Y. This is X bar, this is Y. 0 into 1, 0. 1 into 1, 1. 0 into 0, 0. 0 into 1, 0. So this is the column for X bar Y. Now calculate the column for XY bar. This is X, this is Y bar. X, Y bar. 0 into 1, 0. 0 into 0, 0. 1 into 1, 1. 1 into 0, 0. XY bar is also complete. Now we make the column for XY. Here is X, here is Y. 0 into 0, 0. 0 into 1, 0. 1 into 0, 0. 1 into 1, 1. Now for XY whole bar we negated 1, 1, 1, 0. Now we have to make the column for X bar, Y bar. Here is X bar, here is Y bar. 1 into 1, 1. 1 into 0, 0. 0 into 1, 0. 0 into 0, 0. So now all the columns are made. Now we have to finally make this output for this whole expression. We have to add XY bar, X bar Y, XY whole bar and X bar Y bar. These 4 columns have to be added. Only this column is not to be added. First, second, third and fourth column, these are to be added. 0 plus 0 plus 1 plus 1. Anytime 1 is added, it will always give 1. 1 plus 0 plus 1 plus 0 will give 1. 0 plus 1 plus 1 plus 0 will give 1. 0 plus 0 plus 0 plus 0 will give 0. Now our output has been made. In POS we have to select the rows which has output of 0. In case of SOP we selected the output rows as 1. Now the row with output as 0 will be selected in case of POS. As there is only one row, we will select this only one term. In the column of Maxterm we will write X plus Y plus Z and we will put a bar wherever the input is 1. In this row we said there is no Z here, only X plus Y. So x is 1 and y is 1, therefore both will be having a bar. So we write the max terms here, x bar plus y bar. This is our POS expression. We will consider one more example now. So this is another example of same type of question. They have given an expression x plus yz and we have to find equivalent canonical POS for this. So we have made the raw truth table. There are three inputs x, y and z. So 2 raised to the power 3, 8 rows will be there. 4 zeros, 4 1, 2 0 2 1, 2 0 2 1, 0 1 0 1 0 1 0 1. So now to make this expression, first we will construct this truth table and we need yz. Here is y, here is z. Write the entries here. 0 into 0, 0, 0 into 1, 0, 1 into 0, 0, 1 into 1, 1, 0 into 0, 0, 0 into 1, 0, 1 into 0, 0, 1 into 1, 1. So the column yz is complete. Now we need the full expression x plus yz. X is here, yz is here. 0 plus 0, 0 plus 0, 0, 0 plus 0, 0, 0 plus 1, 1, 1 plus 0, 1, 1 plus 0, 1, 1 plus 0, 1, 1 plus 1, 1. So for POS we have to take those rows which have the output as 0. In SOP we took rows which have output as 1, but in POS we will take the rows which have output as 0 and write the max term as x plus y plus z, addition of literals. Now we have to put the bars. Bars will be on the inputs which have one value, x, y, z. In the first row all they have 0, so there will be no bar in the first row. In the second row x and y are 0 but z is 1, so there will be a bar on z. In the third row x is 0, z is 0 but y is 1, so there will be a bar on y. So three max terms are found. So we have to write POS. First write the max terms here, x plus y plus z. Another is x plus y plus z bar. Then x plus y bar plus z. These are the max terms. These are the sums of literals that are called the max terms. So we have to write POS, that is product of sums. Sums we have written, now we have to do product of them. Dot dot. So this is an expression for POS for this expression. I hope conversion of expression to canonical POS and canonical SOP is now clear to you. Now we will discuss another type of question, type 2 questions of this canonical POS. Now this is the type 2 of canonical POS question. They will give you the truth table and give you one function or directly give you the output. You have to just check which rows are 0 and write the equivalent max terms for this and then construct the POS expression. So 1, 2, 3, 4 rows having the function value as 0. So these are selected and we write x plus y plus z literals everywhere. Now we will check here. In the first row x, y, z, all the three are zeros, so there will be no bar. In this third row x is 0, y is 1, z is 0, so bar will be on y only. Then in this row x is 1, y and z are 0, as x is 1, bar will be on x only. In this row x is 1 and z is 1 but y is 0, so bar will be on x and z. So these are our max terms. Now we will write equivalent POS. First we write the max terms, x plus y plus z, another x plus y bar plus z, then x bar plus y plus z, then x bar plus y plus z bar. Now we have to write product of these sums, so we will do the product. This is the equivalent POS expression for the given truth table. So I hope both the types of questions of POS and SOP are clear to you. Now we move on to the conversion. Now the next topic is conversion of SOP to POS or conversion of POS to SOP, both way. The question can be like this: convert the given POS expression to SOP. They have given you a POS expression, that means product of sums. You have to convert them to equivalent SOP. So first thing is construct the truth table of the given POS expression. We have made the raw truth table for x, y, z, x bar, y bar and z bar. Now we will make the terms x plus y plus z, x plus y plus z 0, 0 plus 0 plus 1, 1, 0 plus 1 plus 0 is 1, 0 plus 1 plus 1 is also 1, 1 plus 0 plus 0 is 1, 1 plus 0 plus 1 is 1, 1 plus 1 plus 0 is 1, 1 plus 1 plus 1 is 1. So x plus y plus z is complete. Now the second term is x bar plus y plus z bar. Here is x bar, here is y, here is z bar. We have to add these three columns. 0 plus 1 plus 1 is 1. 0 plus 1 plus 0 is 1. 1 plus 1 plus 1 is also 1. 1 plus 1 plus 0 is also 1. 0 plus 0 plus 1 is also 1. Do it very carefully. 0 plus 1, 0 plus 0 plus 0 is 0. 1 plus 0 plus 1 is 1. 1 plus 0 plus 0 is 1. So we have made the column for x bar plus y plus z bar also. Now we make the column for this term x bar plus y bar plus z bar. Here is x bar, here is y bar, here is z bar. So 1 plus 1 plus 1, 1. 1 plus 1 plus 0, 1. 1 plus 0 plus 1, 1. 1 plus 0 plus 0, 1. 0 plus 1 plus 1, 1. 0 plus 1 plus 0, 1. 0 plus 0 plus 1, 1. 0 plus 0 plus 0, 0. So we have made it. Now we have to make the full expressions truth values. So that is I have represented by R. R means this expression full. So we have to multiply all these columns to get this expression. 0 into 1 into 1, 0. 1 into 1 into 1, 1. 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 1 into 0 into 1, 0. 1 into 1 into 1, 1. 1 into 1 into 0, 0. So we have got our output. Now we have what to do? We have to convert the given POS to SOP. Now when we convert any expression to SOP, we always take the output as 1. Mark these rows. There are 1, 2, 3, 4, 5 rows. Mark here also. From the above second row, third row, fourth row, fifth row and from below second row. These are all the rows we have marked so that we don't get confused. Now we have to write the minterms. Minterms means product of literals. X, Y, Z, X, Y, Z, X, Y, Z, X, Y, Z, X, Y, Z. Now in case of SOP, as we have to convert it to SOP, we take the 1 from the output and put a bar on 0. Whenever the literal has a 0 value, there will be a bar. Suppose in this row, X is 0, Y is 0, but Z is 1. So bar will be on X and Y. X bar, Y bar. Now in this row, X is 0, Y is 1, Z is 0. So bar will be on X and Z. Now in this row, X is 0, Y and Z are 1. So bar will be only on X. Now in this row, X is 1 but Y and Z are 0. So bar will be on Y and Z both. Now in this row, X is 1, Y is 1 but Z is 0. So bar will be on Z. So we have constructed all the minterms. Now we have to write the equivalent SOP. SOP is equals to, first write all the minterms, X bar, Y bar, Z then is x bar y z bar, then we have x bar y z, then x y z bar, x y bar z bar, then x y z bar. As we have to write sum of these products, so put a sum sign here. So this is our required SOP expression. We have converted the POS to SOP. So I hope this example is clear to you. Note this down in your notebook. Try it yourself. Try 1 time, 2 times, 3 times, and also try other practice questions from any of the reference books. You should have a good hand on this Boolean algebra as it carries the most weightage in most of the streams. Now this is another example. In our previous example, question was to convert given POS expression to SOP, but now here it is convert SOP to POS. We have to do reverse. So this is the expression given. First we will construct the truth table as usual. 2 input symbols are there, so 4 rows 0 0 1 1 0 1 0 1. X bar is reverse of x, y bar is reverse of y. So first we make this term x y bar. Here is x, here is y bar. 0 into 1 0, 0 into 0 0, 1 into 1 1, 1 into 0 0. X y bar made. Now x bar y, here is x bar, here is y. 0 into 1 0, 1 into 1 1, 0 into 0 0, 1 into 0 0. So this is the expression for x bar y. Now we have to make the full result by adding them. X y bar plus x bar y, 0 plus 0 will give 0, 0 plus 1 1, 1 plus 0 1, 0 plus 0 0. So this is our output. Now as we have to convert SOP to POS, in case of POS we select the rows with 0 as output and write the max terms as this. We will write the max terms in case of POS, and we will put a bar wherever the literal is 1. There is no z here, so remove z. There are only 2 input symbols, x and y. So x, y, they both are 0, so there will be no bar. In the last row, x and y both are 1, so there will be a bar on both of them, x bar and y bar. So we can write the equivalent POS as x plus y, x bar plus y bar. As I have to write the product, so I put a product. This is the required POS expression from the given SOP expression. I hope both of them are clear to you. I am giving you some practice questions. Please practice them in your notebook and do them immediately after watching my video. If you don't get anything, please go through the video again and try to understand it again. Now I am quickly summing up all the topics that we have studied. First we studied Boolean Algebra introduction, definition of Boolean Algebra, binary decision. Then we studied about truth table, how to construct a truth table. Then we learned how to make circuits using logic gates. Then we studied laws of Boolean Algebra. We proved them using truth table. We also studied the algebraic method to prove the laws and any other equation if given to you. We studied De Morgan law, which is very important. Then we came to SOP, POS and interconversion of SOP to POS or POS to SOP. So I hope the interconversion of SOP to POS and other things that I have taught in this video are now clear to you. Note that I have uploaded one assignment also, and link is given in the description of the video. If you find any difficulties, you can comment in the videos or you can drop an email at the email address mentioned in the description of the video. If you liked our video, please hit the like button, please share it with your friends, and to see our latest update, please click here. To see our full playlist, please click here, and if you have not subscribed to our channel yet, please hit the subscribe button also. Thank you.